All right, here we go. Okay. All right. Okay. Maybe to go with that. Okay, so here was your exam from last time. We need to use the quadratic formula. Remember the quadratic formula? The solutions to this equation, right, are negative b plus or minus the square root of b squared minus 4ac all over 2a. Those are the solutions to any quadratic equation. So our solutions here, we have negative b, and b is negative 6, plus or minus the square root, b squared minus 4a all over 2a. So there's our answers. Of course, we want to simplify this, right? A negative negative 6 is just 6. And the bottom 2 times 3 is 6. 6 squared is 36. And 4 times 3 is 12. So we have 6 over 6 plus or minus 36 minus 12 is 24. 6 over 6 is 1. See, the square root of 24. 24 is 2 times 12. 12 is 2 times 6. With 1 plus or minus. These two can come out as a single 2. And we can't really do anything with the root 6 here. But we could simplify this to give us a root 6 over 3. So our two solutions are 1 plus root 6 over 3 and 1 minus root 6 over 3. There are two answers. Look at number 2 here. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. We have negative 3 over 4. 3 squared is 9. A minus and a minus give us a plus. 4 times 2 times 4, what, 32? We have a negative 3/4 plus or minus. 32 and 9 is 41. I think is a prime number. So our two solutions, so therefore x is either this for the plus or this for the minus. I'll box our answers. Any questions? All right, so last time we did a lot of algebra. I probably covered it more in depth than I needed to, but I covered it in depth to the level that you have to know for calculus. All right, they're just going to assume that you know the stuff that I covered last time. That's going to be the review chapter, which they're going to probably skip. They're going to give you a bunch of homework and a quiz over it at the beginning of the semester, just assume you already mastered it. The homework in my math lab was, we did it all together. It was only like 10 problems. That was really basically nothing. So I don't want y'all to be unprepared. So I made a practice homework for y'all. It's in here somewhere. This practice algebra. Okay. I put, well, there's like 150 problems in there. I recommend y'all work through those, right? There's no due date, but the more practice you can get with your algebra, the better off you're going to be. Calculus students suffer because they just don't have their algebra down. They might have seen it and might have heard about it, but actually doing it and doing it quick, they just don't have that skill, and that's the problem. calculus is easy. It really is. But if you're struggling with the algebra, because they're just blowing through the algebra, skipping all the steps every time because they're trying to teach you the calculus steps, right? So do this practice algebra assignment, okay? So do the practice algebra, my math lab homework assignment. Okay, it's not for a grade, all right? But if you don't do it, you're gonna suck in calculus, right? You're gonna fail out of college. You want to do it now, not later, right? Save yourself some time and money. So do this, okay? Let's do a quiz then. This will be our quiz 13. See how many we have? 7 people in Zoom. We have 9 out of 12 people present. That's not bad. Seems like most of the class likes to do Zoom. But studies show that students just do better if they come to class, right? And this is a face-to-face class. But I'll throw out the option to y'all. If y'all want to do, so we have 2 days a week. Y'all want to do like Tuesdays Zoom and Thursdays in class? Would y'all prefer that? What's that? Okay. All right. Well, I'll throw that up to the boss and see if they'll allow me to do that. Because it is face to face, you know what I mean? So I don't know if I'm allowed to do that, but I will ask and see. So you'd rather have Thursday Zoom, Tuesday face to face. Okay. All right. Well, I'll find out if we can do that, and I'll let y'all know. Okay. So let's do a quiz here. All right. You should be able to multiply stuff pretty easily, but I want y'all to be able to factor. I want you to factor 4x squared plus 12x plus 5. I want you to be able to factor 18x squared minus 39x plus 20. And I'll give you a third one too. 6x squared minus 19x minus 7. And I want you to actually try to do this, not just sit there and wait until time's run out and then let me do it for you, okay? It's not going to help you in calculus class. So we'll take 10 minutes. I should be able to do these. It's 3:09, so at 3:20, we will work these together. So like when I say y'all can work together, like the way I would try to approach that is work the problem yourself and then compare your answers with your classmates. If y'all got the same answer, you probably did it right, right? One person has something different, that's when you go back and you check your own work. And if you can't find your mistake, then you coordinate with your classmates. Say this not for so much this class, but in the future, your classes are going to get harder. And the only way to get through college is by studying with groups. And a lot of people don't know how to, the logistics of that. How do you make the best of your time? You know, that's just one approach I found that works good. So let's see, looking at these, the first thing you always want to do is factor out a GCF, but you can't get an X out of everything here, and 5 is prime, so there's no GCF here. And because this is not a 1, it's hard to just eyeball it, right? If this was just like that, you might try to eyeball it. But, I mean, so the next step is like guessing, right? You're like, well, everything's pluses. I could have like a 4 and a 1, or I could have a 2 and a 2, right? Or I could have a 5 and a 1, but then I'd also have to check having the 1 with the 4 and 5 with the 1. There's 4 different possibilities. So you could do that and check. You could try all 4 possibilities and check it. But let's just use our trick that always works. Our A times C, 4 times 5 is 20. Our B is 12. We need two numbers that multiply to give us 25, but add to give us 12. So what could these numbers be? Let's see, 5 and 5 won't work. Did I write this problem down? Wrong. Multiply, this is not 25. 4 times 5 is 20. There we go. Two numbers that multiply to give us 20, but add to give us 12. That would be 10 and 2, right? That works. So that tells us we can take this 12x and write it as a 10x plus 2x, 10 and 2. Or you could write 2x plus 10x, it doesn't matter. So if we group now out of the first two terms, I could pull a 2x out. That would give me a 2x plus 5. And now I need to rewrite this as something times 2x plus 5. Well, it's 1 times 2x plus 5, right? So that means we have a 2x, and over here we have a 1, and they're both being multiplied by a 2x plus 5. Boom, factor, right? And we do our touchdown dance. This guy, if we look for a GCF, the first thing I notice is that 39, it's divisible by 3, but 20 is not. Some of these are even, some are odd, so you can't pull a 2 out. Can't pull a 5 out. I mean, 39 is divisible by 13. But there's nothing we can pull out. They are co-primes, or relatively prime. So that sucks. We can't simplify it. We could do our guessing game, but there's a whole lot of numbers that go into that divide 18, right? We could have like a 6 and a 3, or an 18 and a 1, or like a 2 and a 9. And then we have to look at all the combinations that would go with 20. So there's a whole lot of combinations where you tried to guess, it would just suck. So let's try our A times C. All right, what's 18 times 20? What is it? 360. That's a big number. So that kind of sucks, but we can handle this. B is negative 39. So we need two numbers that multiply to give us 360, but add to give us negative 39. If they're going to multiply to give us a positive number, but add to be a negative, they both have to be negative. A negative times a negative is a positive, right? But a negative plus a negative is a negative. So we start trying to guess, like, what numbers multiply to give us 360 here? You know, you might be like, 36 and 10, right? But those don't add to be 39. Those add to be what? 46, right? So try something else. Let's see, 36 is divisible by 18. That's 8, maybe 18 and 20. That gives us 38. That's pretty close, right? So we need to look at something closer here. Something close to these two numbers, right? These two numbers added to be too big. These are slightly too small. What else can we try? Bit of a 20. How about like a 21? No. And 2. No. 24. 24 and 15. I just typed in the calculator 36, and I just started the numbers near 20. I tried 21, but it gave me a decimal. I tried 22. Then I got to 24, the calculator spit out 15, and I was like, aha, those add to be 39, right? So we're gonna have negative 24 and a negative 15. Right, a little trial and error there. So there's a little bit of guessing involved. So that means we can rewrite this negative 39x is negative 24x minus 15x. And out of these first two terms, let's see, we could pull out a 6x. That's the biggest thing we can pull out. That would give us a 3x minus 4. And we need to turn this into something times 3x minus 4. We could pull out about a minus 5. That would give us a 3x minus 4, right? The minus times a minus would give us the plus. So we have a 6x and a, not an x, it's a 5. Sorry about that. All right, 15x and then, okay. So we have a 6x and a -5, both times a 3x minus 4. Boom. We're done. So this last one, 19 is a prime number, so there's nothing we can factor out. This thing doesn't have an x, so there is no GCF. The 6 here is going to make it kind of complicated. Really, there's 4 different combinations. We could try a 3 and a 2 or a 6 and a 1 combined with a 7 and a 1. Okay. So there's 4 combinations, but then there's these signs here. So the minus sign, plus sign could be moved around. So that would give us 8 different combinations if we're going to try to do guessing. So let's not do guessing. A times C, what's 7 times 6? 42. And what's our B here? Our B is minus 19. So we need 2 numbers that multiply to give us a negative 42, and add to give us a negative 19. If these 2 numbers are going to multiply to give us a negative, one of them has to be negative. One has to be positive. Because positive times a negative is a negative. And we're going to end up with a negative number. So the number that's negative has to be the bigger number. So we start looking at combinations. All right, we need a big negative number and a smaller positive number to add to give us a minus 19. So we look at combinations here. We could do what, like 21 and 2, right? Negative 21, yeah, negative 21 and a positive 2. They multiply to give us negative 42, but they add to give us a negative 19. So we can rewrite this minus 19x as a minus 21x plus 2x. And we'll do our grouping out of the first 2 terms. We can pull what, a 6x out? No, not a 6. A 3 maybe. We get a 2x minus 7. And we need to rewrite this as something times 2x minus 7. Well, it's going to be a 1. So we have a 3x, and we have a positive 1, both being multiplied by a 2x minus 7. Boom. There's your quiz for today. Hopefully y'all all could manage to do those on your own. All right, if not, practice. Again, do the practice assignment. I made you a practice algebra assignment in my math lab. It might be down near the bottom. Okay, I don't know how to move it up. Let's see. How do I make it like problem homework number 10 or something here? Settings for class. Maybe I can just click on a number. I don't know, maybe if I change the due date. May 1st. Maybe that'll move it up. No, still at the bottom. Okay, I don't know how to move it up on the list. But make sure you do it, okay? It's at the bottom there. Okay. So look at bottom of list of assignments. Okay. Okay, so now we've covered this stuff and this, which was from the ARF, which I guess is the appendix. So now we're in 2.1. Y'all should have done all your homework assignments in my math lab up to this point here. Where are they? These ARF ones, homework 9, homework 10, and this quiz. All right, should have done the quiz by now. Okay, because we are now in section 2.1. All right, so you should have homeworks 1 through 15 done. All right, put that up here. You should have my math lab homework numbers 1 through 15 done by now. Okay, you don't want to fall behind. Always comes to the last day of the semester and students are asking me for an extension, and it's like, the semester's over, dude. There's nothing I can do for you. You want to keep up, right? And doing this homework on time, you'll get a lot more out of it than trying to do it after, too late. Because we're using that stuff to learn new stuff, So like, if you didn't learn it before you're supposed to, you're missing out. All right, so functions. Y'all probably heard of these before. A function is a mathematical object where we'll like to call them F. You plug a number in and a number comes out, okay? It maps a number to a number. In calculus, you're going to deal with operators, where you plug a function in and a new function comes out, right? Y'all know like functions, you can graph a function and look, this thing has a slope, right? And it just so happens for this example, the slope is the same everywhere, okay? But functions that are curvy, right? The slope here is different than the slope there, right? So depending on the value of x, the function is different. So if this is f in calculus, f prime is the slope. The slope depends on where you're at, right? It's different here, different there, different here, different there. That's all calculus, what you're going to do in business calculus, okay? And then interpret that. And it's all slope, but what is slope? It's rate of change, right? So starting here, we're starting off with just the idea of a function, all right? A function, these graphs didn't exist up until recently. Like this whole idea of an XY coordinate system is kind of new, right? They were dealing with functions way before we could visualize them, okay? So the thing is if you have an equation with two variables, if you rewrite it where y is by itself, you can write it as a function, right? We like to do that. We would take this, we would take the 5x and move it over, and then we would divide both sides by 8. 40 divided by 8, whatever, I don't know. We would take this and we would call it f of x, okay? So you have three things going on here. Y equals f of x. This is the input, that's the output, all right? So some equations can be portrayed as a function. Not all equations can. Like if you have x squared plus y squared equals 1, that's the equation for a circle, right? But that's not a function. It can't be written as a function because it doesn't pass the vertical line test. Thing about a function is one number in, one number out. Well, look at this. If I have one number in, I'm getting two numbers back, right? That's why it's not a function. If you tried to get the y by itself, you would get this, and then you would get plus or minus the square root of 1 minus x squared. So plug one number in, you're getting two numbers out, okay? So not all equations can be written as a function. This is really two functions. Here's one of them, the positive version, and then here's the other one. So you'd have to break this up into two separate functions. Okay, does that make sense? All right, but we like to sketch the graph, right? Just like you would graph this, right? You have your x's left and right, your y is up and down. It's the same thing. It's just that we're calling y f of x. Sometimes we just write y of x. Y is a function of x, right? But we like to have a name for the input, the name for the output, and a name for the thing that turns the input into the output. In applied math, you'll often see they won't have this. They will just write like this, y of x. This is not y times x. It looks like it, right? They're saying y is a function of x. Because it kind of is, right? When you write it like that, obviously y is a function of x. But you can invert this and say, no, x is a function of y, right? The one that we called x and the one that we called y is totally arbitrary, isn't it? Right? But if you switch out the y for the x and the x for the y, this is going to be your x and this is going to be your y, right? What that does is it flips your line over y equals x, all right, is what it does if you switch x for y and y for x. The points right here where X and Y are the same, those points don't move, they don't change. Because if you're switching them, if they're the same thing, switching them doesn't do anything, okay? Keep that in mind when we start doing inverses. But you can do point by point plotting, right? You can plug a number in, plug in an X, see what your Y is, plot that point, do that over and over again and to connect the dots. But that sucks, right? It's like the most boring way to do it. So we went, y'all already know how to graph, like, did we do graphing in here already? Slope and all that? Yeah, we did that a lot, right? We had our inequalities and whatever. So point by point plotting, y'all know how to do this already. This one's kind of complicated here though, right? Let's look at like this guy, right? Obviously, if X is 0, Y has to be 0, right? If X is 1, Y has to be 1, right? If X is minus 1, right? Minus 1 squared is 1. Let's see. Doesn't work out here though. Because if X is 1, Y could also be minus 1. You see that? Minus 1 to the 4th power is still 1. If X is minus 1, Y could either be 1 or it could be minus 1. Because minus 1 squared would be 1. And minus 1 to the 4th is 1, right? So this is not a function. You can see right here that I can make X be 1 and Y could either be 1 or minus 1. Okay, so you have a single number is going in, but what's coming out is two different numbers here, right? So that can't be a function. It's still an equation and we can graph it, okay? So we always want to fixate on functions, especially in calculus. But functions are just a thing in math, right? Just because it's not a function doesn't mean it's not a thing. It just means it's something else, you know? So the goal here is if they gave you something like that, you would try to get the Y by itself, right? So you would like take the 4th root of both sides, right? So you would get Y equals, I don't know how to do this, it'd be complicated. Let's see, I know the square root of Y squared is the absolute value of X. I know that. All right, so if I was going to try to manipulate this, I would be like, well, this is the square root of the square root of y to the 4th, and y to the 4th is y squared squared. So I would have y squared squared, right? That's y to the 4th. And the square root twice would be the 4th root. So knowing that the square root of x squared is the absolute value of x, I would be like, well, this is, let's see, the absolute value of y squared, right? And so on. I'm not sure what they would, oh, they just want us to do point by point plotting here. Never mind. So plug in numbers and see what comes out, plot the points, and you get something that looks like this, okay? That's 9 minus x squared. You recognize that as a parabola, right? Y'all know parabolas. Anything that's highest power is x squared, it's always going to look like that. When I look at this, I'm like, really, this is negative x squared plus 9, okay? So x squared looks like this, but it's negative, so it's upside down instead, and then we're adding 9, so it moves up 9 notches. That's how I look at that. I don't plot point by point by point. That would be mind-numbing, right? This is a version of x squared. It's been flipped upside down and moved up 9, okay? This one I'm not so good at. These 4th powers, let's see what they have for us there. They just do, there's what it looks like. So this is something that I haven't played with very much. Things to the 4th power, you know, I would think of this more like x squared equals z squared, where z is y squared. That way it's something that I would, understand. But you're getting 4 of these, right? You're getting 2 sideways parabolas out of this if you plot them all. Okay, I don't know what this is called. I think it's like a ellipse, but inverted, right? You start off like this, but if you take the focal points and bring them together, once they've crossed, you end up with it flipped inside out. So this is, I think this is elliptical. Okay. We don't need to go into that deep analysis. They just want you to know you can plot it point by point. Definition of a function: one number in, only one number can come out. That's the definition of a function. Okay. If you look at these, here's tables. These are mathematical relations. Which ones are functions? Okay. One number in, one number out, right? You don't have like 2 arrows coming out of a single number, do you? Right? So over here, this is not a function because one number in, you're getting 2 numbers out. All right. So function, not a function. Y'all know the domain is the input, the range is the output. When I say the output, I'm talking about what comes out. When I say the domain, I mean the numbers you can plug in where you actually get something back. All right, that's the domain. All right, that's enough vocabulary. Functions specified by equations. If we can look at this. Looks like a long, boring paragraph, though. Let's see if we can get through it quickly. Most of the functions in the book have domains and ranges that are infinite sets of real numbers. The graph of such a function is called the set of all points x, y in the Cartesian plane. The Cartesian plane is your xy coordinate system, invented by Descartes. Okay. Let's see. So given this example, all right, you could plug in any number you want for x, right? So the domain is any real number. And if they're looking at the area, right, the area depends on x, and it's the length times the width, right? So if you can plug in any number you want, no matter how big or small, then you can get any number you want out as well, right? Here we'd probably restrict ourselves to x has to be positive, right? Because otherwise it would make sense, right? A negative length. Actually, negative lengths do make sense, all right? If you think about a triangle, a right triangle that you put on the XY coordinate system, this is what you do in pre-cal. We like to talk about angles. So this point, if you pick a point, that point really is a triangle, right? Just give me a point. You could think of it as a triangle, right? Here's your Y, here's your X, right? So if you gave me a triangle that had negative lengths, like if I gave you a triangle with a negative X, I would still think of a triangle. I would just think about it being over here instead. All right. So these negative numbers, you wouldn't think of a triangle to have negative lengths, but you want to. The negative sign just tells you the orientation, right? If the X and the Y were both negative, I would be thinking about a triangle over here. If the X was positive, but the Y was negative, I'd be thinking about a triangle oriented like that, okay? So open your mind up to what negative numbers can represent. It's not always just debt, okay? It can represent other things that we can actually wrap our mind around. Independent and dependent variables, right? The X is independent. It can be anything at once. The Y depends on X. That's why I write it Y of X. Y depends on what X is. Of course, you can invert some of them, right? Some functions are invertible. Some functions aren't. We'll get to that here shortly. Determine which of the following equations specify functions with an independent variable x. This one you totally can get y by itself. We've done that over and over again, right? And you can get y by itself, and we can go ahead and do it. 4y, 3x plus 8, so y equals 3/4 x plus 2, right? One number in, we're only getting one number back. It's a function. This guy's a little different, right? If I rewrote this, I would have x squared plus 9, so y would be the positive negative square root of x squared plus 9. This is not it can't be written as a function. One number in, I'm getting the positive and negative back. So no, okay, can't write that as a function. Okay. This is easy stuff, right? So far, y'all know this stuff somewhat. Okay. More than. All right, can I get the y by itself? I can try. I get it x to the 4th plus 9. If I take the square root, though, all right, one number in, I'm getting two numbers back, the positive version and the negative version. So no, can't be a function. This one, you already know that's a line, right? If you graph that, that's a line. Any straight line is going to be a function, right? For one x, there's only one y, right? Graphically, this means passing the vertical line test. If you draw a vertical line and it only crosses your line once, then it's a function, okay? So something like this, that's not a function, right? So for this x, I'm getting two different y's. So that's the next thing, vertical line test, okay? So the one on the left, the straight line function. One on the right, these are the two that we just looked at. No, they're not. These are new ones. Function, not a function, right? Give me an x, there's two y's, so that's not a function, right? It's still a thing. It's still an equation, right? And just the top half is a function, just the bottom half is a function. But so this is basically an inside-out circle. You know a circle, x squared plus y squared equals 3, well, 9. That's a circle of radius 3, right? Y'all remember equations for circles? No? All right. You know the Pythagorean theorem, right? Okay. What it would be a squared plus b squared equals c squared. So if I called a x and I called b y, and then this is a number, I'll say 9. All right. You look at this and you think a triangle, right? Like this, A, B, C, right? Right triangle. Okay, well this, I'm just saying, this is X, this is Y, and this is 3, okay? So if X and Y can change, think about this. Here's a circle of radius 3, right? Okay, every single point on there is kind of a triangle, right? So you all know this is a triangle, okay? So if I said a squared plus b squared equals 3 squared, this is the collection of all right triangles that have a hypotenuse of 3, right? Well, if you're calling these x and y, and you're putting it in an xy coordinate system, right? The collection of all right triangles of hypotenuse 3, 3, 3, 3, right? Every one of these, here's your x, here's the y. Here's the x, here's the y, right? So this is the collection of all right triangles of hypotenuse 3 forms a circle, right? These points, each point is an x and a y, right? Every single one of these points, no matter what that x and y is, the x squared plus the y squared is equal to 3 squared. So that's why when you see this, it's like, it's not a big leap from a triangle to a circle, right? Except a circle really is a collection of an infinite number of right triangles, mathematically. That's what it is. Does that make sense? All right, and then this equation of a circle is also your distance formula. Did we use the distance? We didn't do that yet. All right, they say, check out your distance formula. The distance, let's say I have 2 points. Here's P2 and here's P1, right? So this point is X1, Y1, and this point is X2, Y2, okay? The distance between these 2 points, meaning the length of that line, is x2 minus x1 squared plus y2 minus y1 squared. That's your distance formula. And you're thinking triangles, circles, distances, those are all 3 totally different things, right? No, they're all the same thing, right? If I square both sides, I have this, right? A squared plus B squared equals C squared. See that? This is your Pythagorean theorem. So how does that work? Well, look right here, this triangle, all right? There's the distance between them, right? This right here is your difference in y's, right? Here's your y2, here's your y1, right? So the difference in your y's gives you that length. And then over here, this side of the triangle, if this is x2 and this is x1, right? That length is x2 minus x1. Does that make sense? So this is just one side of the triangle, that's the other side of the triangle, and this is the hypotenuse, right? So when you take the square root, that's the distance formula. It's just the Pythagorean theorem, right? So Pythagorean theorem, the circle is the Pythagorean theorem, the distance formula is the Pythagorean theorem, and so everything's just the Pythagorean theorem, okay? Vertical line test, I already told you that. If you draw a vertical line, if it crosses twice, not a function. Okay. Linear functions. If it's a straight line, it's linear, right? If it's not a straight line, it's nonlinear. All right, so finding the domain. You can't take the square root of a negative number, right? I mean, you totally can, but you'll get an imaginary number. So if you're restricting your world to only real numbers, then you only want the numbers you can plug in where you get a real number back. So if we're restricting ourselves to that, then x here has to be less than 4, right? X has to be less than or equal to 4. Yeah, because if I put a 6 in there, that's a problem, right? I mean, I can plug negative numbers in here. 4 minus a negative is a positive number, right? So as long as x is less than or equal to 4, I'm going to get a number back. So that's the domain, okay? So this guy here, x has to be bigger than or equal to 2, right? If I plugged a 1 in there, I'd have a problem. Can't take the square root of a negative. I mean, you totally can, but you're going to get an imaginary number, which are totally cool. But we're trying to restrict ourselves to just real numbers for now. Function notation. Okay, so functions, there's lots of different ways to visualize things, right? You could think of a function like mapping this to that. So functions are maps, just like that derivative operator I showed you in calculus. You plug a function in and a different function comes out, and that different function tells you the slope of the original one, right? That's just one kind of operator. These are all mappings, right? Mathematics is really all about mappings and the relationships between them. So here we're going to map a set of numbers to a new set of numbers, right? These are our x's, and here's our y's, okay? So these are all mappings, okay? If you look at this thing is kind of like x squared, right? X squared. This is going to contribute to like a shift, right, or a stretch. There's only 4 things you can do: move left and right, move up and down, stretch vertically, or stretch horizontally. That's what's going on here. Okay. All right, what do they want us to do? function evaluation. When they say evaluate, they just mean plug a number in and see what comes back. So like f of 6, just replacing x with 6. That's what that means, the word evaluation. Y'all know what that means, right? F of 6. This is not f times 6. We're just replacing x with 6 here. Boop, boop, right? So like, check this out though. F of x is what? 12 over x minus 2, right? That's just what it's given to be, okay? That's what they told us. What is f of a plus b? All I have to do is replace x with a plus b. Okay? So it doesn't have to be a single letter. I could put anything I want here. It could be a plus b over c. Then this would just be an a plus. Just replace the x with whatever you put here, you put there. Does that make sense? Okay. So that's all they're doing up here is evaluating. Let's say I have f of x is x squared, all right? F of a would just be a squared. F of b would just be b squared, right? What's f of a plus b? Well, the input's getting squared. It would be a plus b squared, right? Which you know is a squared plus 2ab plus b squared, right? This is not f of a plus f of b, right? Because this is just a and this is b, right? So just be aware of that kind of stuff. That will show up constantly in calculus from day one, okay? So y'all know how to evaluate functions here. Let's see. Let's do another one here. Let's look at this one. What's f of 3? Where's our f of x? Here's our f of x. What was our h of x? H of x is the square root of x minus 1. Okay, so if we take that, do you want this guy? Well, what is f of 3? F says put 12 over your input minus 2. What's h of 5? H says take the square root of your input minus 1. All right? And from there, you just do your math. You have 12 over 1 over the square root of 4. 12 over 1 is 12. Square root of 4 is 2. So this is just 6. By the way, the square root of 4 is 2. It's not positive or negative 2. It's just 2. All right? This is a common misconception. If I'm solving x squared equals 4, right? The steps for this, I would take the square root of both sides. This is the absolute value of x. The square root of 4 is just 2, okay? Why is this the absolute value of x? Because if I plug in a positive or a negative and I square it, I get a positive number. And the square root of a positive number is a positive number. So even if I plugged in a negative 2 here, negative 2 is 4. The square root of 4 is just 2, the positive version, okay? So to drop the absolute value, that's when you get the positive or negative, okay? Y'all see the square roots a whole lot doing examples like this. So it's a common misconception. People see this and they're like, oh, this is both positive and negative too. No, it's only the positive version, okay? Okay, that's 4 o'clock. Y'all want to take a short break? Yeah, let's take a break. Break it down. Break. We will resume at, I don't know, 4:07. We'll take like a